Chapter 8 Design Process. Designing a successful airplane is a matter of proper planning and managing the risks posed by unknowns. In contrast to this, a subjective trial and error approach can fail to produce a successful plane within budget. This happens for two reasons. Firstly, an airplane is a complex machine. Apparently small changes can have several unrelated consequences to flight behavior. If your design is fundamentally poor, you will never be able to sort it out. Secondly, there are a huge number of design variables that can be changed. There are multiple parts of a plane that can be edited to fix the same flight quality. This becomes mentally taxing, choosing which part has to be fixed after each test. 8.2 A Practical Approach. Study previous designs, but only trust proven designs. These will be good preparation for building the prototype. They also provide intuitive knowledge if your numbers produce wacky-looking designs. If your design looks wacky, double-check your numbers. Building the prototype offers a great opportunity for trying out new construction techniques. It is better to experiment on prototypes than final products. When building a prototype, keep in mind that it has a short lifespan and will require repairs and design changes. At least one prototype will probably have to be destroyed and thrown out. For this reason, keep prototypes inexpensive and expendable. 8.3 Define Goals. Defining a set of requirements is a necessary prerequisite for success. Create as tight a set of constraints as possible. 8.3.1 Ungoals. In line with defining your goals, you should also make a list of what you don't consider important. 8.3.2 Airplane Size Scaling Ideas. Learn the rules for creating scaled designs. This is covered in my previous video on this book. DARPA recently funded research into micro-air vehicles. These are planes with a maximum linear dimension of 6 inches. 8.3.3 Materials. Choose materials based on market value and ease of manufacturing. The price premium for best is a lot compared to good enough. Wood works well as a building material most of the time. 8.3.4 Construction Difficulty. A design's complexity should match the builder's skill level. 8.3.5 Performance. Nothing compromises designs faster than multiple performance goals. These could be climb rate, cruise speed, cargo capacity, or flight duration. Pick one performance goal to optimize and run with that. 8.4 Flight Testing. In-flight computerized data recorders can perform this task. Having objective data is useful. Sensors that rely on air pressure are hard to calibrate and prone to measurement errors, so try to mainly use other sensor types. 8.4.2 Robustness. The laws of aerodynamics are unforgiving and the ground is hard. A design may need to be resistant to construction or control input mistakes. Were some construction steps substantially harder? What could you do to simplify it? Is there a maneuver hard to do? Is the CG in the wrong spot? Could a different material be used? One school says that structurally you should lighten any part of the plane that did not break in the last crash. 8.6 Final Thoughts. Many so-called original designs are actually rehashed existing designs. Always study other airplanes to learn the process of a designer. Try and make design decisions that solve multiple problems at the same time. In the best designs, all parts work together in harmony. Here is a list of design tools that the author uses for plane designing. Let me know if I should cover any of these design tools in more detail.